Hello and welcome again to the Skillwork Forum, where I'm joined with my partner Brett. And Brett, we get together and talk about technology, robotics, computers. Now, actually, we don't typically, but
it's a theme lately.
Yeah, it seems to be a theme lately. Actually, we talk about skilled trades and particularly manufacturing, but we are going to talk a little bit about one of those topics and the idea of semiconductor and semiconductor manufacturing. This is really a compelling topic. During COVID, one of the things, I think a positive things that came to light was our supply chain was highly leveraged and very risky because it depended on a lot of offshore and a lot of offshoring in countries that aren't necessarily friendly to us. Definitely China, that's a big part of those. And there was a lot of industries. We discovered that like medical, biomedical, and technology, particularly semiconductors or computer chips, are all developed almost 90-something% offshore. And I don't know if you remember, Brett, but even here, during that, we couldn't get computer monitors. We had like 4 months wait time to get a laptop because all the stuff is being made over there. So as a result of that, actually the government every once in a while does something fairly sane and makes a lot of sense. They passed this bill called CHIPS. You're going to talk about a little bit more, but essentially it's how do we bring back semiconductor manufacture back over here? How do we invest in the ability for us to bring the manufacturing, the actual creation and building of computer chips, semiconductors back here in the States? So what have you learned about this topic? And how does it affect the trade?
Tim, I've been in the weeds pretty deep on this whole semiconductor manufacturing and what the challenges are and what's it mean. We'll get into that here in a minute. In total, we've talked about on some previous podcasts, the onshoring or the boom that we're seeing in manufacturing in general, coming back to the U.S. Tim, we were listening to an economist, a while back, and he was saying that not just in the semiconductor space, but manufacturing in general was going to be, they are building plants to bring stuff back because of what we dealt with supply issues, back, unlike since the 50s, and a portion of that, which has arguably the one that maybe has the most security risk tied to it is the semiconductor, manufacturing. And so, first of all, I got to tell you what CHIPS means because whoever came up with it was incredibly creative. So CHIPS, which obviously we say, microchips, but it's creating helpful incentives to produce semiconductors. I would have never guessed when I saw the CHIPS Act that's what that actually stood for. And so
sounds like a high school marketing team won the award.
I know. And so, so the government, as Tim said, once in a while they spend our money in some things that I think are probably in the right things, and we'll see if we see the results of it, the way we want to. But they've at this point, they're spending $55 billion on incentives, tax breaks, a variety of programs. We'll talk about those a little bit later. It's a pretty extensive list that they're doing to kind of drive the support of what it's going to take to make this manufacturing come back.
So $55 billion.
$55 billion.
Wow, that's almost how much we sent to Ukraine last week. No, just kidding. Just not going to go there.
So we'll edit that out. And so we'll be shut down.
As a joke. Yeah, absolutely, 100% on board.
You didn't say you disagreed with it.
No.
Said that's what we said.
It's just a fact.
And so, as I think Tim alluded to a minute ago, so about 90% currently, about 90% of the semiconductors, so the chips, and if you stop and think about it, there's a microchip in just about everything anymore. I mean, it's currently a $550 billion industry projected to go over $1 trillion by 2030.
Is that domestically or globally, or is that the whole?
I think that's the whole.
Yeah.
I think that's the whole of the industry. Because Europe actually passed a similar act at the same time. So Europe is, which in our thought, I think, as a country, I think if Europe expands their production, so we're trying to go, the goal for the U.S. is to basically bring back 20%. So get to 30% of our own manufacturing of semiconductors here in the U.S. But the other piece of that is, like I said, Europe is going through a similar, so another portion, so will be coming from there, which we think are people that might work with us a little more.
So we're the goal by the end of the next, by 2030?
2030.
So we want to go from something less than 10% to 30.
Yep.
Of our domestic need.
Needs.
We want to, it's almost like energy independence. We want to bring that back so that we're less dependent.
Yep.
And when people think about what are microchips, what are computer chips, semiconductors, basically that is the brain that allows everything from your smartphone to your security system at home to the camera that we're looking at to operate.
Yep. And it just becomes, as you know, believe it or not, I was having this conversation with my wife, Sally, recently. We were talking a little bit about this. And I graduated, before I went on and got my business degree, I have a 2-year degree in digital electronics, of which I graduated in 1986. So what was then digital electronics, we were working on circuit boards, capacitors and resistors. I mean, it was a board. So that which didn't really do that much. You had a bunch of these boards and a piece of equipment. Now that's all done on a chip that does a million times as much stuff. It's the reason why the thing that we carry in our pocket everywhere is more powerful than what used to be the original computers that took up half of a house.
Yeah, well, this is I'm wearing a smartwatch, right? And the computing capability in this smartwatch continues to astound me and surprise me. It tells me stuff. I'm like, oh, I didn't know it did that. It's incredible. Yep. So this is going to drive, and we just talked in a previous podcast about the technology, pace of technology advancements. Without this, you don't get there. Yep. And if we have to depend on anything offshore, particularly our adversaries, it's just a security threat, and it's definitely going to, we saw it during COVID, it will bring our supply chain to a standstill.
Yeah, well, it makes, I mean, the big one that I think a lot of people remember besides computers was it crippled the auto industry. I mean, it was when you'd go and there was no cars on the lots.
Yeah.
And it was all semiconductor. They didn't have the semiconductors, the chips.
They're all smart cars.
To put in that vehicle. So,
well, you're talking about construction and manufacturing, and all you have to do is get out. I was in Boston this last week, and Boston, one thing about it I liked about it, it's got a lot of history. It's just old, but all in that area, downtown Boston, building, cranes, new construction, all over the place.
Yep.
Incredible amount of building going on. And everywhere we go, we see it. Roads, highways, airports. It's just our own airport here is undergoing a big renovation.
Yeah, so you've got a combination of all this manufacturing, construction for manufacturing facilities, plus then you have, in addition to the chip bill, the government also passed the infrastructure bill, which that you can decide whether you like that one or not, but that's what's driving. So, they threw, even more than $55 billion, at that. But the point of all that is it's putting a huge demand on the construction space. So, but specifically in this space, so the construction is underway in multiple sites in the U.S. So the primary, and there are some outliers of this, but there are multiple facilities being built in Arizona, Texas, Ohio. Columbus, Ohio has a couple plants being built. New Mexico. So those are kind of the hotbed. There's others. Upstate New York has some, depending on who they are. The main players, one of the things we'll talk about here in a minute is interesting. Most people don't know companies that make semiconductors. And we're going to get into it here in a minute. The biggest risk by far to meeting these goals is the skilled trade gap.
And that brings it back to what we typically talk about here. That's why we're talking about this.
Exactly. So the main players, and I'm going to guess only two of them, or maybe a couple of them people know, Intel. Intel was smart enough years ago to put their little label on every computer that said Intel inside. But most semiconductor companies don't do that. So now you're trying to attract a kid out of high school to go into this, most of them don't even know what semiconductor production. They know what semiconductors. So there's a bit of a brand, but Intel, Texas Instruments, Micron is a big player in semiconductor production. Samsung, there's 3 or 4 others, but those are probably the biggest ones. The earliest right now, the facilities, the startup is late 2024, but most of those projects, because these plants are pretty sophisticated, as you would expect, and so the shortage of not just construction workers, but the construction workers who can do this high-level installation of this equipment and stuff. So a lot of these projects already are getting pushed, back to 2025. But you're going to continue over the next 5 to 6 years as we inch our way towards 2030. Tim, this isn't something they're talking about. I mean, the dirt is digging. There are plants there's a plant, I can't remember where it's at, that is done, but they haven't opened it yet because they can't find the help.
That's what gets back to our main issue here. We talked about the why, there's a risk, there's supply chain vulnerability, but notwithstanding the construction needs and, getting the lines up and running, to operate these facilities, they're going to need not only a much larger number of the formal degree engineering type folks, computer scientists, but they're calling them, the technicians.
Yep.
And these are the higher end skilled trades. These are people with like 2-year certificates, trade school, in this specialized ability to work on this equipment, monitor it, maintain it, program it, et cetera. There's a huge and growing gap there that's 30,000 plus are going to be needed at a minimum, 30,000 just for this. Well, they're competing with all the other industries that are also need the same skill set. So it's great that we're investing, we're growing, but everybody's recognizing, man, where are we going to get these folks to work in these plants? That's what I think we really want to talk about.
It is, yeah.
The challenge.
No, it is a major challenge. You can read a variety of reports, and Deloitte to McKinsey. I mean, everybody has written this because it's a big opportunity from a manufacturing standpoint, but it's also a big opportunity for us as a country, from a security risk standpoint to bring this back. But without any question, the number one issue is the talent. Is their current projections indicate a shortage, of up to 90,000 skilled techs, computer engineers, scientists, as we talked. But 90% of the jobs in these facilities will require skilled techs and skilled operators, not the engineers. The engineers are mostly doing, to be honest with you, we do over 50%, I think, of the development is already done here in the U.S. We just have it all manufactured, outside of the country. So now you're trying to bring that back. So we need a lot more engineers as well. But from kind of where we live in our world, is that, as you indicated, Tim, they're right now at the pace they're on, they're figuring in the best case scenarios, they're still going to be 30,000, short. And there's kind of two combinations. These plants are, you need the skilled technicians who can keep the equipment running. You need the operators who are going to be more skilled, and type of thing. But these facilities are also very climate and clean facilities, because of what they're making. And so you need skilled technicians in HVAC and air and there'll be a whole utilities that every one of these plants are going to require. And we know, because we live in that, where those individuals are already hard to find. Now you need to find one that has that skill and can work in this environment, which is even a little more, skilled. And like you just said, here's the reality. This industry, the semiconductor industry, which is on this manufacturing boom, it's not like everybody else said, yeah, you just take them all. We don't need them. So they're competing with aerospace, with automotive, advanced manufacturing, cybersecurity, we talk about sometimes. It's the same individuals. At least they're the ones with the same skill set. It's just a question of which way are they going to go. If you're in college or you're a senior in high school or whatever, and you're in the STEM program and you're going to go get that 2-year degree. We're going to talk about that in a minute, kind of what they're doing to really steer people into this direction. That kid is way more likely to go, well, I'm going to go work for Google or I'm going to go work for Amazon, because they don't even know who Micron is.
Yeah.
And so they've got to kind of reestablish an identity.
Yeah. There's an education aspect to this. And I do think that they recognize that a big part of this investment is not only incentivizing manufacturing, the building, rather the construction, but they know that they've got to incentivize and put funding towards the education and training. Not only the engineers, but I've been reading some stuff about they're going to develop these boot camps. So I've heard of boot camps for software developers. You go in an intensive period of time, learn how to do basic coding. There's going to be boot camps for technicians that can work here. There's going to be opportunity for kids coming out of high school or 2-year junior college or technical school. That, man, they're going to have a great opportunity to make a really good living working in a clean environment. So this is a skilled trade. You know, they call them technicians. They call them robotics technicians and other manufacturing domains. But it's still high-end skilled trades guys who know how to do things with their hand, who can think, who can troubleshoot, can repair, install, replace. It's the same thing, but it's very exciting to think about what's being done. So this CHIPS Act funding is creating all these organizations that are designed to study this problem, to provide avenues for education. Tons of universities are starting to do it. More and more community colleges are coming online. So there's going to be tons of different pathways. We have to continue to get the conversation in schools, high schools, to guidance counselors that, get off this, the only path forward is a 4-year school to get some degree in humanities.
Yep.
These are the opportunities that are coming our way all over the place. And this is really exciting for us because we want to be one of those solutions to this, providing these guys.
Yeah, 100%. We want to be a seat at the table. We'll talk about, kind of this holistic end-to-end, talent transformation that's got to happen. And this one, Tim, as you know, obviously we provide, we have augment maintenance teams all over the country, but this one is just a little different because of the security and how fast it's coming in your building. But the security that, some product that we have guys in today, if they're making, whatever, chocolate milk or insulation or whatever. I mean, it's important, but it's not a country security issue. This is one we really have to figure out. And so, but there, as you can tell, that this industry as a whole, and whether the Intels of the world and whatnot are driving these pieces, the conversation is clear based off of everything that's being done. They're now creating, you mentioned it a minute ago, Tim, so studies in microelectronics is now a specific 2-year. So as you just said, most of these folks that are working in these plants as technicians, as skilled technicians, what do they need to have with a 2-year degree in what? And that's what they're trying to figure out, because the reality is, my reference a little bit ago about to what I learned in digital electronics in 1986, I'm probably not going to be much help to somebody that's doing that. So they're creating studies in microelectronics. Purdue University, which is a big engineering school, but they've now created a semiconductor degree program. UT Austin has a Texas Institute for Electronics. What you're also seeing is several of these community colleges that are close to where these plants are being built. So you're seeing this partnership between, say, an Intel or a TI, whoever it is, with the local community college. Hudson Valley Community, which I think is in upstate New York, is so they now have a 2-year semiconductor program. So you're seeing that all of this happening, which is a clear indication that as a whole they realize in order to pull this off, somehow they've got to get the talent.
Yep.
And so the thing that is probably one of the most concerning or opportunistic, however you want to look at it, from our seat, I just mentioned, Hudson Valley Community College, and it is in upstate New York, and there's a Global Foundries plant that's being built up there, facility, and they're estimating right now they need to hire about, with turnover and everything, they're going to need to hire about 300 a year
300.
of skilled technicians. Hudson Valley just completed their first course on the skills.
Like the first class.
Yep, 12 people. So herein lies the problem. There was another example of another company that did it, and they were estimating even higher numbers of their needs, and they graduated 4 people.
Yeah.
So there's just not enough, people coming in.
That's this idea that is attractive to me, this boot camp, where you have these, something we really have invested in is upskilling, where it's you take a guy that's got some of the basic skills and aptitude and put him in an intensive 9-week, something like that. Focus where, they may not learn some of the ancillary, theory, but just here's how you do it. As a matter of fact, I have a military background, and a lot of the military schools that you go through, equivalent to 2-year education or even 4-year degree, but they're designed to teach you this is what you actually have to do the job. Yep. It's focused because they're trying to crank out people that can day one do the job. And it's kind of that model that they're going to have to turn to. So some of these higher education organizations and facilities that you mentioned, they're going to have to change their mindset too. Tech schools that we work with, they've kind of got that model. They're trying to crank out people that can do the job day one, not show up and you got to train them how to do their job. So it's pretty exciting, and I think the future here, and we are certainly excited about it. There is a great opportunity for people that want to get into this, and I think great opportunity for companies that are going to really be creative, innovative to bring in some of this new talent. So we're bullish on it.
No, we're very bullish on it, and kind of to your point, Tim, we're seeing it in our industry a little bit, through SOCA certification, for example. So there's a thing called SCS, so it's a semiconductor company standard, but it's exactly what you were saying, Tim. What they're recognizing, we've got to make sure that we're training these individuals for what we need them to do the job. So you're seeing all this effort, which is really interesting. That's why I think it's very opportunistic for us. If we have an automation technician today that's working in another service, that person, if he can learn this skill set, he's now, he's opening up that opportunity, and then obviously bringing more. So companies, are going to have to. We need to win at this one, and it's going to take kind of an end-to-end transformation. They're going to have to work with the local communities. Obviously, the whole STEM graduate incentive. They've got to get kids coming out of STEM programs to realize, to your point, that this is an opportunity, that this is something I want to know better. This is a cool environment. It's a cool opportunity. I can make good money in this. They're going to have to drive more brand awareness. And then in our space is where we want, to have a seat at the table as well. You've got to expand your reach. So you got to augment the pipeline at all levels, which is what we do every day in some space.
Yeah, so, this is, you mentioned it a couple of times. I don't think it's hyperbole to say this is a national security threat. If we don't bring this onshore, and there's also some other industries, definitely biomedical is one. We got to bring that, our ability to go here. We've lost that ability. We pushed it overseas because of cheap labor. And it's crucial that we bring it back here to shore up our supply chain, our ability to keep that. And we've talked on other podcasts. All these other facilities, all these other manufacturing facilities, they need this semiconductor input to be able to run all of the other technology that's coming. So it is very symbiotic, and it's something that we definitely have to embrace. I'm glad to see that there's investment being made, and we certainly plan to be here for the ride over the next 10 years. Hope we can close that gap.
Yep, absolutely.
So, thanks for joining us here on the Skillwork Forum. Interesting conversation. We try to bring in things that relate directly to the skilled trades, and this one definitely does. So this is not your father's skilled trades anymore. The future is not, and it is very exciting and compelling. A lot of challenges, but a lot of opportunities. So thanks for joining us here on the Skillwork Forum. As always, we really appreciate it, and God bless till we talk next.